Hi, I'm Alex Martinez, and today I bring to you challenge number 4 of DataWeave. In this case, we are going to see some Tower of Hanoi mathematical puzzle. If you are not familiar with it, don't worry, I will explain the rules of the game for you, and then you can just go ahead and try it out on your own. We will have 3 different scenarios that you can see in the article, so if you're watching this from YouTube, go into the description of the video and click on the article in ProsDev so you can see the 3 different payloads that we are going to check. But for the first payload, we will have this one right here. And you can see here, since this is kind of a game, it will contain the number of moves. So you will be responsible of updating this field every time that you move one of the disks. Here you can see the total number of disks for this game. In this case, there are 3, and here you can also see that there are 3. Then the target tower that we are going to move this to is to the tower C, or the stick, or the stack, or whatever you want to call it. I'm just gonna call it tower because it's just easier for me. And here you can see the 3 different towers like A, V, and C. So now let me show you a visual representation of what all of this means in case you're not familiar with the game. So this is the Tower of Hanoi game, basically. Here we have 3 disks, which is the one that we just saw in the payload. We start at 0 moves. And the thing is that there are some rules, like one rule is you can only move one of the disks per turn or per move. So here you can see that it says minimum moves 7. So all of this puzzle can be solved with at least 7 turns or 7 moves. So you can only move one of these disks at a time from one of the stacks to the other one, or one of the towers to the other one. And the other thing is that you cannot put a bigger disk on top of a smaller disk. In this case, this is the first one, or number 1, number 2, and number 3. So for example, you cannot put disk number 3 on top of disk number 1 or disk number 2. But you can put disk number 1 on top of disk number 2 or disk number 3. Let's solve this quickly. Done. So we did it on 7 moves, as it was the minimum moves to do. Now all you have to do is to do the same thing, but on DataWeave. So once you finish doing all of the changes in DataWeave, you will end up with a payload similar to this one, where we have 7 moves, we still have 3 disks, the target tower is still the same, is C. The towers are A and B are empty now, as we also had in our previous game that we solved, and now the 3 stacks are gonna be here. So here in C we have 1, 2, 3. And they are also in order. They are not 3, 2, 1. They are 1, 2, 3. So the same thing you will have to solve and get to this answer. There are other 2 scenarios that I can show you right here. This is the second scenario. Here we only have 4 disks. We have all of the 4 disks in Tower A, and we are going to move them to Tower C. So that part is still the same, but the rules of the game might change a little bit. Well, not the rules, but the way that you code this might change a little bit depending on whether this is an odd or an even number. So pay attention to that. And finally, the third scenario here, I am going to change things a little bit to make sure that you all are not cheating. Here we have 7 disks. The target tower now is Y. Now we're not using A, B, and C. We are using X, Y, and Z. So very important that you don't hard code the name of the towers in your code. You have to make them dynamic. So now that the target tower is Y, and we started with all of the stacks, all of the disks on the Z, we're gonna move the Z to the Y, and this is how this is gonna end. This was done in 127 moves. And that's it. I really hope you like this challenge. Remember to subscribe in the YouTube channel or in prosdev.com so you can keep receiving notifications as soon as new content is available for you. I will keep doing these challenges for you, so please subscribe so you can get up to date all the time. Good luck! Bye-bye!